friends, today we are going to learn how an air conditioning system works. The fundamental principles and concept behind its operation. I saw many videos here explaining the same thing, but no one seems to be talking about the fundamental laws behind an air conditioning unit. In this presentation with few diagrams, I will try to explain the real working principle of an air conditioner, as simple as possible. To understand air conditioning system, we just have to learn only these two laws, the gas laws and the first law of thermodynamics. These two are the fundamental, basic laws on which an air conditioning system works. They're really simple to understand, and I will explain how they are applied in an air conditioning unit. First, the gas laws. Temperature of a gas is directly proportional to its pressure. It means when the pressure of a gas rises, the temperature also rises in the same proportion, and vice versa is also true. When the pressure decreases, the temperature also decreases in the same proportion. And the second law we have to learn is first law of thermodynamics. This law says that heat always flows from higher temperature to a lower temperature. As we all know that as water flows from higher level to lower level. In similar manner, this law says that heat always flows from a higher temperature to a lower temperature. I hope these two laws are clear and they are quite simple. The first one says temperature is directly proportional to pressure, and the second one says heat always flow from a higher temperature to a lower temperature. Let's understand what the gas law says with illustrations. Suppose if I have a gas in a piston cylinder arrangement at a certain pressure and temperature. When I increase its pressure by compressing it, like this, its pressure increases. So according to the gas laws, as the pressure is increased due to compression, its temperature also increases. Now if I release the pressure by pulling the piston back, the temperature also reduces. Coming to an air conditioning unit, the gas used in an air conditioning system is known as refrigerant. A refrigerant is not a natural gas like air or nitrogen, oxygen or helium. The refrigerant could be ammonia or some hydrocarbon compounds. You can look them up on the internet. They are used because of their effectiveness and performance. Coming to the working of an air conditioning unit. Suppose you have an air conditioning unit installed at your home or office. When you switch on your air conditioning system, what it actually does is, it absorbs heat from the air inside your room and throws it to the outside air. So when it absorbs the heat, the temperature of the air inside your room reduces. But how the system physically do that? How the various components of the air conditioning system and the refrigerant together accomplish that task? Let's start from the most common or familiar component, the compressor. As the name suggests, its function is to compress the refrigerant. Let's assume the temperature of a refrigerant in an air conditioning system is 32 degrees Celsius. It will be a couple of degrees higher or lower to the ambient temperature, depending upon the various factors. The ambient temperature in this case is 35 degrees Celsius, and the pressure of the refrigerant inside the air conditioning unit, let's assume that is 1 atmospheric. Atmospheric or ATM is a unit of pressure. I am using 1 atmospheric pressure for the refrigerant only for our convenience and easy understanding. Now, when the system is switched on, the refrigerant at 32 degrees Celsius and 1 atmospheric pressure enters the compressor, and the compressor compresses the refrigerant. Due to compression, pressure of the refrigerant increases. According to the gas laws, when pressure rises, the temperature also rises. You can see here that the pressure has increased from 1 atmospheric to the 5 atmospheric after the compression. Due to the rise in pressure, the temperature of the refrigerant, which was 32, it has risen way above the outside air temperature. Our outside air temperature could be up to 50 degrees Celsius. But, after the compression, the temperature of the refrigerant will be in the range of 60 to 80 degrees Celsius. In this case, I have assumed the temperature to be 65 degrees Celsius. Now, the refrigerant is at 65 degrees Celsius and it flows towards the outside unit called condenser. The condenser allows exchange of heat between the refrigerant and the outside air. Since the refrigerant is at higher temperature compared to the outside air, heat transfer takes place between refrigerant and outside air. This heat exchange is happening according to the first law of thermodynamics, that heat always flows from the higher temperature to the lower temperature. As the refrigerant loses its heat in the condenser, its temperature reduces. Thus, temperature of the refrigerant when it comes out of the condenser will be around 40 degrees Celsius, slightly higher than the ambient temperature, which is 35 in this case. From the condenser, the refrigerant flows towards another component called throttling device. Its function is to release the pressure of the refrigerant. You can see in the diagram that we still have that 5 atmospheric pressure that was available at the outlet of the compressor. Since pressure doesn't change in the condenser unit, the pressure will be same when refrigerant flows through it. The condenser only allows heat exchange between refrigerant and the outside air. It doesn't change the pressure of the refrigerant. So, we still have that 5 atmospheric pressure intact with us at the inlet of the throttling device. Now, when the refrigerant goes through the throttling device, its pressure reduces. The pressure is reduced from 5 atmospheric to 1 atmospheric. But we have learned that according to gas laws, if the pressure reduces, the temperature also must reduce. So, when the refrigerant comes out of the throttling device, its temperature will be way less than the room temperature or the desired temperature set by a user, which could be 20 degrees or 22 degrees Celsius. But our refrigerant temperature at the end of the throttling device is around 8 or 10 degrees Celsius. This cold refrigerant now flows to the inside unit of an air conditioner called evaporator. The evaporator allows heat exchange between room air and the refrigerant. Since the refrigerant is at lower temperature compared to the room air, heat flows from the room air to the refrigerant. The refrigerant absorbs heat from the room air, thus reducing the temperature of the room air. The room air gets cooler in the evaporator and the absorbed heat is dissipated in the condenser to the outside air. And the cycle is repeated continuously. To sum up this air conditioning cycle, the refrigerant absorbs heat from the room air in the evaporator. It gets compressed in the compressor, where its temperature rises way above the outside air temperature, so that it can lose heat at the condenser. And later on, when depressurized in the throttling device, the temperature reduces way below the room temperature or the desired temperature, thus becoming capable of absorbing heat from the room air in every cycle. And the cycle repeats and the room gets cooler continuously or the temperature is maintained. I hope you got the idea behind an air conditioning unit and its various components. One might ask about the evaporator and condenser, why they are called so. It is because in an air conditioning unit the refrigerant keeps changing its phase. At one stage it will be liquid and next stage it will be vapor, and liquid again. At the inlet of the evaporator the refrigerant will be in liquid phase. As it absorbs heat from the room air, the refrigerant starts to evaporate, hence when it comes out of the evaporator it is completely in the vapor state. Similarly, at the inlet of the condenser the refrigerant will in vapor state. As it loses heat to the outside air, the refrigerant starts to condense into liquid phase, hence the name condenser.